Okay. Hey guys, in this video we are going to start chapter 8 on polynomials, and what I want you to know about each of these videos is that you're expected to take a few notes each time you watch a video and bring those notes to class with you so that you can share them with your group and ask questions and get some of your questions answered as well. In section 8.1 we're going to be finding measures of angles in polygons, both regular and not regular polygons. And on the first slide you see the definition of convex and concave. So you're going to be expected to know the difference between the two. You can write down what you need to off of these for your definition. You may already know the difference between convex and concave. I like to think of a concave polygon as one that looks a little caved in, and convex that does not. And then we're going to talk about the angles inside those polygons. All of the ones on this slide are convex polygons. We all know that the sum of the angles in a triangle is 180 degrees. And what we're going to be able to do is find the sum of the measures in any polygon, regardless of how many sides it has, by looking for a pattern. If I take a four-sided polygon and divide it into triangles, you'll see that we can make two triangles from one vertex by drawing in a diagonal. When you divide up your polygon into triangles, you never want your diagonals to cross. So you're only making diagonals from one vertex. And then knowing that each triangle sum is 180 degrees, you can find the sum of a four-sided polygon by taking 2 times 180. If you have a five-sided polygon and you divide it into triangles, from one vertex you can draw 2 diagonals, which gives you 3 triangles. If you take 180 for each of those 3 triangles, the sum of the measures inside a pentagon is 540 degrees. For a 6-sided polygon, you can make 4 triangles. Hopefully you're starting to see a pattern here. You take 180 times 4, and you get 720 degrees. In a 7-sided figure, you can create 5 triangles, each at 180 degrees. Leaves you with a sum of 900 degrees. Because of that pattern, we have a formula. There are always 2 less triangles than the number of sides. Multiplying that by 180 gives you the sum of the interior angles of a polygon. If you only wanted to know the measure of one of those angles and all the angles were equal, then you could divide that sum by the number of sides, which is also the number of angles. Okay. Remember that that type of polygon is called regular. So when you see the word regular, you don't want to overlook it. You want to remember that all the sides and all the angles are equal. And you could find the measure of one interior angle by dividing by n. In a polygon, the sum of all the exterior angles is always 360 degrees, regardless of how many sides you start with. Your book has a great drawing of taking some exterior angles, cutting them apart, putting them all together again into a circle, which shows the 360 degrees. Again, it doesn't matter how many sides you have, the exterior angles always add up to 360 degrees. Okay, so let's try some examples. In this first one, we have a 5-sided polygon, and we need to find this angle measure right here. The formula here says n minus 2 times 180. That will give us the sum of all the measures inside of a pentagon. Okay, so if we take 180 times 3, which is how many triangles we could create by drawing in diagonals, we get 540 degrees. You take that 540 degrees and you subtract out the angles we already know, the 112, the 102, the 98 and the 57, that will give us the one that's left. So I'm just going to do that quick subtraction. 540 minus 102 minus 112 minus 98 minus 57. That leaves us with 171 for x. Next example asks us to find the sum of the measures of the interior angles of a polygon that has 20 sides. We know that if we had 20 sides, we would be able to make 18 triangles on the interior, multiply each of those by 180, and we have 3,240 degrees inside that polygon with 20 sides. In the next example, we already know the sum of the interior angles is 2,160. And we want to know how many sides we have in that polygon. Remember, the number of sides and the number of angles is the same. So I'm going to take this formula, set it equal to 2,160, and solve for n. Some of you might think of it this way: if you take the sum of the measures of the angles and divide it by 180, that tells you how many triangles could be made inside that polygon, and then add 2 for the number of sides, because there's always 2 triangles there are 2 vertices you can't connect to make a triangle. So this polygon has 14 sides. In this problem, we know the measure of an interior angle, and that's just one angle. Our polygon is regular, which means all angles are equal. So we're going to take this formula to help us find an angle, or how many sides the polygon has, and set it equal to 165 degrees. Solving for n, we're going to multiply by n first. I'm going to distribute the 180. I'm going to subtract the 180, and then divide by negative 15. There are 24 sides in this polygon. On this example, we know we have 4 exterior angles. One of them is missing. We know that they all add up to 360. So if we take 110 plus 88 plus 124 plus m, that's going to equal 360. And then if we subtract the ones we know, we should be left with m. So 360 minus 110 minus 88 minus 124. The missing angle is 38 degrees. Remember, you can watch this video again if I went too fast or if you need to complete your notes. Next thing I want you to do is answer the questions on the next slide and bring them to class with you.